Hi, this video is on normal distributions and we're looking at populations and samples. So hopefully what you'll learn here is how to use the stats mode on your CAS calculator to find the mean and standard deviation of a sample, find estimates for the mean and standard deviation of a population once you have that, and then use the information from the sample and normal distributions to make predictions about populations. So here's a sample population type question. A sample of 40 leaves was taken from a tree and their lengths measured to the nearest millimetre. The results are recorded in the table below. Find the mean and standard deviation of the lengths of the leaves in the sample. Now, we're not asking you to do this using sort of by hand using the formulas. So we're going to use the calculator to do it. What you have to do is put the information into a table in your calculator. So what you need to do is bring up your stats mode. So if you go to statistics, clear out anything that's in there, and all you need to do is put in a list. So we just type in the information here, 34, 39, 41, 42, and it all goes in list 1, so we don't need list 2 or list 3. Okay, so I've now put all of that data into that list there. Now these happen to be arranged from descending to ascending. That isn't important in terms of working out information about this data. It just happens to have been arranged that way. I could have put this in any order and I would get the same results for the next bit. So in order to find the mean and standard deviation, rather than calculate them the long way, we're going to go to calc, one variable. We've just got one list, one bits of information. My X list, so my list of data is coming from list 1. Frequency is 1, so basically there's no frequency table. This isn't a frequency table where a second column would be used, which you can do here. You can set up a second column. We're not going to do that. Frequency is 1, so everything in the list occurs once is what we're telling you. Okay, so when you hit OK, you get a bunch of stat calculations here. You get the mean, X bar. You get the sum of X. You get the sum of X squared. You get here, this is the standard deviation of our sample. Sx we'll come on to in a minute. N is the number of items in there. You get the smallest value, the min x. You get the Q1, we've talked about quartiles. The median, so 50% of the data lies below or equal to 67.5. Q3, the highest value, the modal value, and other bits. Oh, sorry, and that's saying that there's one mode and 58 occurred 3 times. That's mode frequency. The ones we're interested in here are X bar, which is the mean, so that's 64.825, and this one here, sigma X, which is 15.9904. Now, Part B says estimate the mean and the standard deviation for all the lengths, of the lengths for all the leaves on the tree. So this was a sample of 40 leaves, but there would be many, many more leaves on that tree. This was the mean and standard deviation of our sample. Now it turns out that providing you have sufficient data, so if you've got a good number of pieces of data, we've got 40 here, that's plenty, and if they're randomly taken, then the mean of our sample is a good estimator for the mean of the population. So we are going to say that mu is 64.825. That's our estimate. Now it turns out that this here is not a terribly good estimate. It's not bad, but it's not the best estimate for the standard deviation of the population. Now you can correct it by recalculating with n-1 instead of n. Now remember, n was 40 here. If we recalculated using 39, we would get a better estimate for the standard deviation of the population. It corrects to within a couple of percent for a large proportion of the time. So that was the value that you saw there, that was Sx. And on other calculators you might see sigma n-1 would be another way of writing that. So if we go back to our calculator, you can see we've got this Sx value of 16.1942 to 4 decimal places. That's what we're going to use. That is our estimate for the population of, for the standard deviation of the population. So 16.1942. I think if you're using a ClassPlad 300, I think it says sigma n-1, which is the same thing. So they're both 16.1942. Now that we have these estimates, we can make predictions about leaves on the whole tree. So X is modelled by a normal distribution with mean 64.825. We're going to use our unbiased estimator, which is this 16.1942. 42 squared. That's our model, and we can then solve some different problems, such as what is the probability it's less than 45. So we want to know probability that x is less than 45, and we use the calculator and just go back to your main screen and normal distribution. So distribution continuous, norm CDF, lower bound is negative infinity, so we'll pick that up there. So negative infinity to 45. Our standard deviation is 16.1942, mean 64.825, so there we go, it is 0.11, so 11%, 0.11 or 11% chance that it's below there. Probability that it is between 50 and 70 would be that proportion there. It doesn't matter if it's less than or equal to or less than, we get the same value. And we solve that on the calculator. So lower bound 50, upper bound 70, and click OK, and it's 44.54%. Our final question 3, probability it's more than 80, so we're interested in that zone there where that's 80. Probability that x is greater than or equal to 80, or sorry, greater than 80. And solve it on the calculator again. This time it's 80 with an upper bound of infinity, positive infinity, same mean and standard deviation, and we get 17.44%. There we go. So, providing you have enough data, so 20 odd pieces of data is plenty, 40 was lots there, and the sample is random, then the mean of a sample is a good estimator for the mean of a population. The standard deviation of a sample is not a good estimator for the population, but S of x or sigma n minus 1 is. So use that. And if you use the estimator, you can then make predictions about the population from your sample, like we just did. Okay, that's it. Thank you.